In this video, I'm going to show you how to work with exponents, both positive and negative exponents. And again, guys, I want you to write this down. Write down whatever you see on these papers. That's what I want you guys to write down. All right, so 4 to the second power means this. It means 4 2 times, which, by the way, equals 16. Okay? But this does not mean this. It doesn't mean, -4 times -4. It doesn't mean that at all. 4 to the -2 means this. It means whatever this is, I put it in a fraction. Right now, this says 4 over 1 to the -2. So when I'm doing this, I flip this number to the 1 over 4, and I put that -2, well, basically it goes down here, but I can take the whole thing squared now. The negative goes away. So that's going to equal 1 times 1 is 1, 4 times 4 is 16. So 4 to the -2 means I turn it into a fraction. That's the reciprocal. I make the reciprocal. I take that negative away, and then I just multiply it, by itself twice. All right? So we're going to do a few of these. So what if we say x squared plus y to the -3? Well, how would we do that? Well, the x square is okay by itself because it's positive. It doesn't have a negative exponent. But we can never have a negative exponent. So this is what we have to do. We have to take that y to the -3, because right now that's a y over 1. So we're going to have to flip it like this. So we're going to have x squared plus 1 over y, to the third power. That's how we have to write that. I could have put that 3 down here too. It might be more easy for you guys to see it if I do it like that. But do you see now how both of the exponents are positive? We have to have positive exponents. We can never have it where it's not a positive exponent. All right, let's do another one. What if I say 2x to the -3 times y to the 4th. I can't have a negative exponent. All right, this guy is fine. He can stay. I call this going upstairs and going downstairs. This guy is fine. He's going upstairs. He's going to stay where he is. That -3 exponent, does that apply to the x? Does it apply to the 2? Does it apply to both? You might not know this. It only applies to the x. It doesn't apply to the 2. The 2 has an invisible 1 exponent right there. So the only thing I have to do in this, to write this equation correctly, I'm going to leave the 2 upstairs, 2, and I'm going to leave the y upstairs, y to the 4th, divided by x to the 3rd. Because the x is now, x over 1. Now I have to switch it so it's 1 over x. But do you see how I don't have to put the 1 up top, guys? Because it would just be 1 times 2. Well, that's 2. So I don't have to put that 1 up there. I can just leave it like this. 2y to the 4th divided by x to the 3rd. I got rid of the negative sign, and now it's fine. Okay, let's do another one. Okay, 10x to the 3rd y to the negative 5, 2z to the 10th power. What goes upstairs, what stays down? And these are all times in the middle, okay? So it's times that, times that. Well, the 10x cubed is fine. It's all positive. This is not fine. This is fine. 2z to the 10th. But this guy here, I have to put downstairs. And I turn him into y to the 5th. All right? Now they're all positive exponents. I can never have a problem that has a negative exponent in it. Let's just do one more. Well, no, I'm going to do a backwards one here. So what if I say 5x to the negative 3 divided by y to the negative 4. Now what's the problem? Now I've got a bunch of negatives. So I have to put this guy down here, and I have to put this guy upstairs. What about the 5? The 5 is okay because the 5 just has a positive 1 exponent by it. So my answer is going to be 5. I'm going to put this guy upstairs, y to the 4th divided by x to the 3rd. See, when I move these things, the exponents change their signs. So this changes from negative to positive, and this changes from negative to positive. All right? Let's try this. What if I would say 2x to the 3rd times 5x to the negative 2? What happens when you multiply things like this? What happens when you multiply with exponents? Remember what you do? You add them. You add the exponents, but you multiply this guy. So 2 times 5 is 10, right? X to the 3rd times x to the negative 2 means I add, which is 3 take away 2 is just 1. So it's just 10x to the 1. See that? Let me show you another way to write this. 2x to the 3rd, I could keep upstairs, couldn't I? Because it's just the same. But what do I have to keep upstairs here? Just the 5, right? Times 5. And then this x squared, I have to put downstairs, x squared. All right, let's just try this. 2 times 5 is 10. This is 10 x to the 3rd. I'm just going to multiply it like that. Then I'm dividing it by x squared. What happens when you divide exponents? You subtract. So 3 take away 2 is just 1. So this is going to equal 10x to the 1 power, which is exactly what we got there. All right, so remember, when you're multiplying the exponents, x squared times x to the 3rd, you're going to get x to the 5th. When you're dividing the exponents, instead of adding x to the 6th divided by x to the 4th, you're going to subtract and get x squared. Okay?